Hello, y'all. This is Darrell Lee Berry Jr. back doing some more reviewing for my exam today in a few hours, what, 3 hours? Uh, I will focus on some proof stuff right now. So I think I have the calculation stuff down pretty much, even though I have to work on the different ways of doing a matrix multiplication. Uh, but I mean, I know how to multiply the matrix. It's just there's those few methods that are still new to me. But I think I know well enough to backtrack from the dot product method. It's not that we can't do a particular method, we just might be asked to do a specific one. So we could always do the dot product one and then backtrack. Um, I would say most of the stuff I have down except for the proofy type stuff. Like there's solve a system of equations, got that. Find a normal to two vectors and hyperplane. Solve the system of equations of the dot product. Easy enough. Um, but the proof stuff is what I'll focus on. So I'll do some proof stuff. If I have time, I'll solve the system of equations. The last one we just did, echelon form and row echelon form, to see what the difference is. And it looks like any row where there's either all zeros or all numbers where there's no pivots is a free row. There's a pivot and it has some kind of solution. All numbers are zeros, it's a free variable. So I'll write that. And still, by the way, my not sure why my the book is not always showing properly, but thankfully I'm not doing much of the book today. So let's go to the iPad. All right. Oh, so this is probably minimized. There we go. Just in case I do need the book. All right. So free variable. The last time we did echelon form, row echelon form, we know that in this case there's a the one is the pivot. All the ones are pivots. Zeros are in the other pivot rows. So that's reduced row echelon form. So what we'll do is do some proof things so I can work on that. Right? Exam review. Now let's see what we're looking at here. Right? So I know vectors will do that later. Okay, 9 proof. It says let A be an n by n matrix. And let B be an Rm. Right? So B has the same number of rows as A, has the same number of, as rows A have. Show that if U and V and Rn are both solutions, right? So AX equals B. So AX equals B. X equals U and V are both solutions. So AU equals B and AV equals B, since they're both solutions to AX equals B. So we have M by N times, and it says V is an M, which it would need to be. So U and V would have to be in something, and that's going to be M by something. Show that if both U and V are solutions to AX equals B, then U minus V is a solution to AX equals 0. Right, that's easy enough. So by distributive property of systems, AV plus AU equals AV plus U, which equals B plus B equals 2B. But what that also must mean is AV minus, or AU minus AV equals B minus B, which equals 0, which equals AU minus V by the distributive property. Therefore, U minus V solves AX equals 0 with X equaling U minus V. Sure, that's good enough. If anybody pops up and you can see a different way of solving it, go ahead and chat here, and we'll keep it rocking. Right? So another proof, the most dreaded things. Right? So we have a matrix, no free variable. So we have every row with a pivot. Every row has a pivot. AX equals B is consistent. So if it's consistent, that means it has 1 plus solutions for X. If it's consistent, it has 1 or more solutions. If it's inconsistent, it has 0 solutions. The rank of A equals R equals N. So it has as many pivots as it has columns. So every column has a pivot. Every has at least 1 solution. Every column has a pivot. Suppose so it has a therefore unique solution if and only if AX equals 0 has only the solution of X equals 0, which they call the trivial solution. And AX, A is a n by n matrix with rank equals n. every row in the number of pivots equals the row in columns was a square matrix, non-singular. I have to remind myself what non-singular means. So we need the book after all. So it says an n by n matrix of rank R equals n is called non-singular. An n by n matrix of rank R less than n is called singular. R equals n, non-singular. So it's just a definition. R less than n is singular, right? But that still doesn't remind me what singular is. So, proposition 5.5. If it is non-singular, which means that is a square matrix in R and the number of the rank, the number of pivots is, spans the full matrix. That also is to say it has only the trivial solution to equal 0, because there is a value for every single pivot, and for every b in Rn, the equation has a solution, a unique solution. So every b has a unique solution because the rank spans the full matrix. Let's specify rank again. All right, so here we go. Let's go back a little bit. So here, our strategy now is to transform the augmented matrix. And let me split the screens here. So the augmented matrix is when you take a line, and B. Our strategy is now to transform the augmented matrix of any system of linear equations into echelon form. So remember, echelon form means all the leading numbers of a column are pivots. You can have any numbers up here, but all zeros down here. And every leading number has zeros underneath of it. And the leading numbers are in sequential order down the columns, along the columns. Oh, let's scroll. Let's scroll. Hold All right. In general, given an m by n matrix, you might wonder how many conditions of vector b in Rm. So it has b has as many rows as the matrix has rows. Must satisfy in order to be a linear combination of the columns of A, because that whole vector B, all the columns of A add up to make that column. From the procedure we've just followed, the answer is quite clear. Each row of zeros in the echelon form of A contributes one constraint. each row of zeros contributes one constraint because in order for all of that to equal zero, something particular must happen. This leads to our next definition. The rank of a matrix A is the number of non-zero rows, the number of pivots in any echelon form of A. It is usually denoted by R. So rank, think row, the number of pivots. So each row that has a leading number with zeros underneath, count those up, that's a rank. And the number of rows of zeros in echelon form is n minus R. M is the total number of rows minus the rank, which is you have a pivot, and that'll give you all the zeros. So B must satisfy n minus R constraint equations. That makes sense. So for instance, this equation here, the rank is two pivots, but its M is three rows. So M minus R is one, so it has one row of constraint equations. Right. So the definition of rank, maybe I'll call this one, well, proof one. I'll take a moment to think about that. So think about rank, understand what rank is. Understand the constraint equation is going to be the total number of rows minus the pivot rows, which are the ranks. And the difference of that will be zeros so that you have constraints on the system. Thing is that the system has to meet in order for that system to be a consistent system and have solutions. So the math jargon is starting to make sense. So I'll take a break and I'll be back.